as well as the Potenza. Distinguished ladies and gentlemen, my lords, spiritual and temporal, leaders of our academic community, great veteran, on behalf of our Vice Chancellor, I welcome you all to the 192nd in the inaugural lecture series of this great university. Today's lecture, titled Radio and the Firmament, a Marriage of Heaven and Earth, will be delivered by Adekunle Titus Adediji, Professor of Physics Communication. A round of applause for the inaugural lecture. In consonance with the tradition of this university, this inaugural lecture will be presided over by our Vice Chancellor, the very first female Vice Chancellor of this great university, Professor Adediji Adediji, Fellow, Academy of Science. She is joined here by other principal officers. The Deputy Vice Chancellor Academic, Professor Timothy Amos, you are welcome, sir. The Deputy Vice Chancellor Development, Professor Sunday Samuel Oluyamo, you are welcome, sir. We welcome the Chief Scribe of this great university, the Registrar, Mr. Charles Olusegun Adeleye, you are welcome, sir. We welcome the Bursar, Mr. Peter Oladapo Oshaduba, you are welcome, sir. The librarian is here present, Dr. Robert Akiade Awoyemi, you are welcome, sir. And the Acting Provost, College of Health Sciences, Professor Biodun Olaguji, you are welcome, sir. The deans of our various schools they are led by the Chairman Committee of Deans, who is also the Dean School of Computing, Professor Boniface Kayode Aleshe, you are welcome, sir. We welcome the Dean School of Agriculture and Agricultural Technology, Professor Olabode Thomas Adebayo, you are welcome, sir. We welcome the Dean School of Basic Medical Sciences, Professor Akim Olalekan Lawal, you are welcome, sir. We welcome the Dean, School of Infrastructure, Minerals and Manufacturing Engineering, Professor Christopher Olaboluwakunmi Akibile, you are welcome, sir. We welcome the Dean, School of Electrical Systems Engineering, Professor Adekunle Oladipo Melody, you are welcome, sir. We welcome the Dean, School of Health and Mineral Sciences, Professor Ayode We welcome the Dean School of Logistics and Innovation Technology, Professor Olayemi Olasenye Simeon. You are welcome, sir. We welcome the Dean School of Life Sciences, Professor Muftau Olawole Olajumoye. You are welcome, sir. We welcome the Dean School of Physical Sciences, Professor Femi Barnabas Adebola. You are welcome, sir. We welcome the acting dean, new dean, School of Basic Clinical Sciences, Professor Mojisola Uto. You are welcome. We welcome the Dean School of Postgraduate Studies, Professor Oluwayo Bello Olusoji. You are welcome, sir. And we welcome the Dean, Student Affairs Division, Professor David Olarewaju. Okay, you are welcome, sir. At this juncture, it is my singular honor to bring to the podium the chairman of today's occasion, the leader of our academic community, our Vice Chancellor, Professor Adediji Adediji, for our welcome address. Madam Vice Chancellor.
The Deputy Vice Chancellor Academic, Deputy Vice Chancellor Development, the Registrar, University Librarian, the Bursar, my lords, spiritual and temporal, top government functionaries here present, the inaugural lecturer of today, Adekunle Titus Adediji, deans, directors, and heads of department, especially the Dean of the School of Physical Sciences, distinguished members of Senate and congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. It gives me great pleasure to welcome everyone to the 192nd Inaugural Lecture of the Federal University of Technology, Adekunle. I welcome very especially our spiritual and traditional leaders, top government functionaries, captains of industries, friends of the university, and the entire staff and students of the university. I am very pleased to welcome the immediate and extended family members, friends and well-wishers of the inaugural lecturer. I felicitate Professor Adekunle Titus Adediji on this academic milestone. May I at this juncture request the inaugural lecturer to please rise while I read his citation. Professor Adediji, please. Adekunle Titus Adediji was born 14th December 1969 in Ikwetu, Ijesha, Oriade local government in Osun State. After his elementary education, he attended Adediji High School, Adediji Ijesha, Osun State, where he obtained his West African School certificate. Thereafter, he attended St. Andrew's College of Education, in Oyo State, where he obtained the National Certificate of Education in Maths Physics in 1990. Further pursuits of academic excellence took him to University of Ilorin, Kwara State, and Federal University of Technology at Oyo State, where he obtained BSc Physics in 1995, M.Tech Communication and Atmospheric Physics in 2003, and PhD in the same field 2009. Adekunle Titus Adediji joined the services of the Federal University of Technology as Assistant Lecturer in the Department of Physics, School of Sciences in May 2004 and was appointed Professor in October 2019 in the same Department of Physics. He has supervised many undergraduate projects, 39 master's dissertations, and 18 PhD theses. He has authored and co-authored over 100 journal articles in reputable peer-reviewed journals. And he has presented papers at several conferences both within and outside Nigeria. Professor Adediji belongs to several professional bodies such as the International Union of Radio Science Nigeria, Nigerian Institute of Physics, Nigerian Meteorological Society, Institute of Electrical and Electronics Engineering, and Science Association of Nigeria to mention a few. He has served as reviewer of many national and international journals, including the Nigerian Journal of Pure and Applied Physics, International Journal of Physical Sciences, Journal of Microwave Power and Electromagnetic Energy, amongst others. Professor Adediji has had years of experience both in lectureship and management positions in the university system and has served the Federal University of Technology in many capacities. He was head of the Department of Educational Technology, School of Physical Sciences between 2024 and 2025. He was Chief Registration Officer, Department of Physics, School of Physical Sciences between 2020 and 2024. He was Associate Director, Space Research Unit, Center for Space Research and Applications, TESRA, between 2012 and 2017. He was Seminar Coordinator, Department of Physics, between 2007 and 2009, and he was Associate Editor, Nigerian Journal of Pure and Applied Physics between 2006 and 2012. Outside the university, he served as Secretary, Ikwetu Ijesha Merit Award Committee. He was Secretary, Ikwetu Ijesha Higher Education Committee. Also Secretary, Federation of Ikwetu Ijesha Clubs and Associations, all between 2003 and 2016. And he is a member of Ikwetu Ijesha Day Organizing Committee. Professor Adediji is happily married. The union is blessed with children. Radio remains a critical tool for mass communication due to its accessibility and ability to reach remote areas via radio waves. These waves are reflected and refracted by the ionosphere, the layer of the earth able to reflect radio waves, allowing long-distance radio communication. The lecture of today is expected to discuss the importance of ionosphere in radio communication, transmission, and reception, highlighting its ability to transcend boundaries and connect people across distances. The lecture is further expected to enlighten us on how radio's unique capacity to marry technology and the natural world fosters a sense of global connection and shared humanity. Distinguished ladies and gentlemen, we have before us this day a distinguished scholar to present the 192nd Inaugural Lecture of this university, titled Radio and the Firmament, a Marriage of Heaven and Earth. Please join me to welcome Professor Adekunle Titus Adediji.
Vice Chancellor, the Deputy Vice Chancellor, Academic, the Deputy Vice Chancellor, Development, the Registrar, other principal officers of the University, Deans, Directors and Heads of Department, my law, spiritual and temporal, KBSs, fellow academic and professional colleagues, distinguished guests and friends of the University, great and articulate Rotarians, gentlemen of the press, distinguished ladies and gentlemen, the Vice Chancellor. It is generally believed that the journey of an academic reaches its optimal amplitude with the delivery of an inaugural lecture, which usually is a moment of profound reflection, celebration, and unique opportunity to ventilate one's academic achievement, and in particular, the contribution to knowledge and enduring legacy in the chosen field of the inaugural lecturer while still alive, in order to inspire others in the future. However, the occasion is not just about scholarly prowess, but about sharing a life lived in pursuit of knowledge, truth, and excellence. I am therefore delighted and highly honored today to deliver the 192nd Inaugural Lecture of the Federal University of Technology, Akure, titled Radio and Firmament, a marriage of heaven and earth. The inaugural lecture is the 9th from the Department of Physics, the 3rd from the Computation Physics Research Group. The first was delivered by Emeritus Professor L.B. Kolawole, my academic grandfather, on 29th March 1988, and the second by Professor L.O. Adewole, my academic father, on 21st June 2011. This is also the 11th inaugural lecture from the School of Physical Sciences, the first ever by an alumnus of my secondary school, Ejile High School, Ejile Ijesha, Osun State, the utmost for the highest. For this singular honor, therefore, I return all praises and adoration to the Lord of Lords, the I am that I am, the giver of knowledge and wisdom. May his name alone be praised forever. The Vice Chancellor, distinguished ladies and gentlemen, as we gather today to listen to this lecture, it demands of the profound connections that bind our earthly existence to the celestial essence. Across cultures and faiths, humanity has done such to understand the relationship between the terrestrial and celestial realms. For instance, in the Bible account of creation, we read and God said, "Let there be a firmament in the midst of the waters, and let it separate the waters from the waters." Genesis 1:6. And God called the firmament heaven. So the evening and the morning, the second day, Genesis 1:8, God said, "Let there be light," that is electromagnetic waves, "in the firmament of the heavens to divide the day from the night, and let there be for signs and seasons and for the days and years." Genesis 1:14. This firmament, a heavenly vault, separating the earthly from the divine, has captivated human imagination for centuries. Also in Ezekiel 1:25, a voice, that is radio waves, came from above the firmament that was over the earth. Whenever they stood, they laid down their wings. Furthermore, God told Job, "Can you send lightning," that is electromagnetic waves, "that they may go and say to you, here we are"? Job 38:35. The Bible here is making what appears to be a scientifically ridiculous statement, that light can descend as electromagnetic waves and sound, and then manifest itself in speech, that is radio or sound waves. Therefore, the Bible predicted modern telecommunication 1,500 years before Christ, when God said, "Light can descend and manifest itself as speech." In the Holy Quran, a similar concept was found, as Allah subhanahu wa ta'ala says, "And we have made the heaven firmament a roof well supported, and it is they who are neglected of the signs of their Lord." Quran 21:32. Here the heaven is depicted as a protective canopy, sheltering humanity from the unknown. In Surah Al-Anbiya, Allah subhanahu wa ta'ala also says, "And those who disbelieve not consider that the heavens and the earth were a joint entity, and we separated them." Quran 21:30. In another Surah Al-Anbiya, it says, "And it is he who created the night and the day, and the sun," that is electromagnetic waves, "and the moon, all heavenly bodies in an orbit as well." Quran 21:33. Coming up to Yoruba cosmology, Ifa, A sacred system of divination and wisdom is used to interpret destiny and to provide guidance through sacred verses only. Ifa is based on the belief that the microcosm, the immediate environment of the terrestrial, is a reflection of the macrocosm, the universe of heavens. The concept of the firmament is therefore personified in the deity Olokun, who is referred as the guardian of the celestial realm. The Fakokos reminds us Olokun ni Ọlọ́run, Ọlọ́run ni Olokun. Olokun is the owner of the heavens. Of firmament, the heavens are Olokun. The fact teaches that everything is a manifestation of light, that is electromagnetic waves, which is referred to as Ella, and carries primal consciousness. Therefore, the traditional greeting to the spirit of life, when it becomes manifest through possession by the medium, says, Spirit of light, I beg you to leave my body. Spirit of light, I beg you to leave my body from earth. Spirit of light, I ask you to extend my body to the immortals. In metaphysical terms, and I embrace the God in every present moment. Hence, if I describe Ella as Ella Omoshi, Ella Omoyi, Igi Okaoku, Ella Akiokumo. Spirit of light, child of the love, ruler. Spirit of light, child of the spirit of the stone in the water. The spirit of light has descended to earth, we die no more. Also, in glorified glory, it is stated, àwọn ará ọ̀run sọ̀rọ̀, àwọn ará ayé ń gbọ́. The inhabitants of heaven speak, the inhabitants of earth hear. This verse of Ifa highlights the connection between the celestial and the terrestrial realms, and the transmission of energies and information between the two. Ifa believe that radio waves energy can be transmitted through the air or space and received by those who are tuned in. The vice chancellor, distinguished audience, along the lines of the above religious tripods, I therefore humbly invite you to join me on a journey of exploration of the marriage of heaven and earth, as we examine the interconnection between radio propagation communication technology and the celestial realm. Introduction. The Vice Chancellor, distinguished audience, in the 60th, 61st, and 62nd inaugural lectures of this great university, titled respectively, Chaos, Dynamics of Creation, Voyage into the Future, Satellites as Technology Drivers, and Radio and Ray, Friends and Foes. All clearly alluded to the essence of light, that is electromagnetic wave, in the works of creation by the Almighty God. While the 68th confirmed that light brought order to interpret the optical situation according to Genesis 1:2 created by God, the 61st affirmed that the consequence of the order brought about the creation of the atmosphere, that is the firmament, and the weather system. While the 62nd elucidated that God created our atmosphere and ensured that light brought order to it in a special way, and that visible light occupies a very small band compared to the other parts of the electromagnetic spectrum that are not visible. Hence, the paradoxes in the title of today's lecture, radio and the firmament, a marriage of heaven and earth, can be summarized in terms of 1. Bridging the divide. Radio waves as a form of electromagnetic radiation can be seen as a bridge between the earthly and heavenly realms. It transcends physical boundaries, allowing communication and connection between people across vast distances. Cosmic connections. The firmament represents the vast expanse of the universe, while radio waves symbolize our connection to this vastness. This marriage of heaven and the earth highlights our place within the larger cosmic context, encouraging us to explore, understand, and appreciate mysteries of the universe. This concept invites us to ponder the intersections of technology, spirituality, and our place within the universe. The Vice Chancellor, distinguished ladies and gentlemen, through this lecture, therefore, I aim to inspire a deeper understanding of the intricate relationship between radio propagation and the atmosphere, and altogether the wonders of radio and the firmament. Hence, in the course of this lecture, I shall highlight some aspects of my own humble and modest contribution to knowledge of the physics of radio propagation, so communication in the tropospheric layer of the atmosphere in a tropical environment. But before proceeding, therefore, I wish to emphasize that the title of this lecture is so broad, to which it is impossible to do full justice within the limited time available. However, the diffusion is assembling. When the town wins the gun, the breadth of knowledge broadcasting may be justifiably allowed to override this depth. It is therefore that by the end of this lecture, I will have given you some food for thought, not only on the basic facts about radio communication, but also on some of the benefits of getting involved in the study. What is radio? Radio is a technology that uses electromagnetic waves to transmit and receive information, most commonly audio, without the use of wires. The radio communication system consists of several components working together to facilitate information transmission from the source to the receiving end. The components are transmitter, channel, receiver. Radio can be classified by the type of modulation used, which are amplitude modulation, frequency modulation, phase modulation, the frequency band. The different kinds of radio waves, their frequencies, wavelengths, and destination are shown in Table 1. Forms and types of radio communication. Radio communications are designed in different forms for specific purposes and operate within different frequency range and protocols. The various forms of radio communications are, according to Adekunle and Zen 2006, Firmament 2007, Gaya 2021. They are broadcasting, mobile communication, satellite communication, and others. Applications of radio communication. Radio communication is applicable in the following areas: telecommunication and broadcasting, navigation and location services, that is GPS, GNSS, and others. Radio propagation mechanisms. Radio waves propagate in the atmosphere, that is the firmament of heaven, according to several different physical mechanisms, which are free space propagation or line of sight propagation, reflection, transmission, diffraction, scattering, and wave guiding, as shown in Figure 1. Radio propagation environment. The propagation environment consists of the climatology and the geographical databases of the location considered for the description of the propagation of waves between the transmitter and the receiver. This environment is generally described from the physical parameters of the medium. Its climatology, such as pressure, temperature, humidity, or the refractive index, and from geographical databases containing data concerning the topography, vegetation, and land use, the street axis, and buildings, the atmosphere, and radio waves. Atmosphere is a sphere of vapor or a gaseous envelope surrounding a sphere or globe. Therefore, the atmosphere of the Earth is an envelope of air surrounding the Earth. Without this envelope, the life forms we consider familiar will not exist. Hence, in view of the importance of the atmosphere into radio communications, an overview of its makeup will be described in terms of the vertical temperature profile, as shown in Figure 2. It includes the troposphere, stratosphere, mesosphere, and the thermosphere. Atmospheric parameters. The atmospheric parameters relevant to radio propagation and transmission calculations, according to IR 1988, Wingard et al. 2001, are temperature, pressure, relative humidity, saturation vapor pressure, water vapor density. Radio propagation in troposphere. Tropospheric radio propagation refers to how radio waves travel through the troposphere, that is the lowest layer of the Earth's atmosphere. This phenomenon is crucial for various communication systems, including wireless networks, broadcasting, and navigation, as it allows signals to travel beyond the horizon and in areas where other propagation methods are less effective. In the troposphere, the propagation of radio waves is strongly influenced by the gaseous composition of the atmosphere, the presence of aerosols, that is small particles of variable size, in suspension in the air, hydrometeors such as rain, snow, hail, etc. Lithometeors such as dust, smoke, or sand. Microwave propagation conditions in the troposphere. The troposphere affects the propagation of ground waves and can promote communication over large ranges, thereby characterizing microwave propagation as subrefraction, normal refraction, superrefraction, ducting, or trapping, as shown in Figure 3. Hence, in subrefractive conditions, radio waves moves away from the Earth's surface and the line of sight range. In normal propagation, radio signals travel on a straight line path along the Earth's surface and go out to space unobstructed. with super refraction. EM waves are bent downwards to all sides. In ductile trapping conditions, the waves bend downwards with a curvature greater than that of the Earth. Radio propagation in the ionosphere. The ionosphere is the area that enables signals on the shortwave bands to traverse major distances. It crosses over the meteorological boundaries and extends from altitudes around 60 km to 700 km. The density of these charged particles varies with altitude, time of day, season, and solar activity. The propagation of radio waves in the ionosphere depends largely upon the following characteristics of the medium in which the wave is propagated. That is, the homogeneity of the medium, the directional or anisotropic properties, the wave frequency dependence. Some factors affecting ionospheric propagations are frequency, time of the day, solar activity, sunspots and solar flares, season, and location. Practical application of ionospheric propagation are long-distance communication, shortwave broadcasting, and others. Scattering and absorption of radio waves. Scattering is a phenomenon in which the direction, frequency, or polarization of the wave is changed when the wave encounters discontinuities in the medium or interacts with the materials at the atomic or molecular level. Polarization of radio waves. Radio waves produce both electric and magnetic fields. The magnetic field and the electric field are always mutually perpendicular. The direction of the electric component of the field is called polarization of the electromagnetic field. Polarization is one of the most crucial factors in radio propagation. There are three primary types of radio wave polarization, which are linear polarization, circular polarization, and elliptical polarization. Radio wave scintillation. Radio wave scintillation in the ionosphere are rapid short-term fluctuations in the amplitude, phase, and angle of radio signals as they pass through irregularities in the ionospheric electron density, thereby causing signal twinkling similar to the stars. These effects disrupt satellite communications like the GPS due to plasma instabilities at low and high latitudes. Scintillation is one of the key atmospheric mechanisms that have debilitating effects on propagating electromagnetic waves, according to Shimaru 1978, Ibolito 1989. They are caused basically by variation in weather patterns, atmospheric turbulence, solar wind changes, and ionospheric effects. Radio communication through rain. Radio wave propagation is significantly affected by rain through absorption. That is, water molecules in the raindrops absorb some of the radio signal's energy, converting it into heat, and then scattering. Raindrops cause radio waves to deviate from their original path, scattering the signal in different directions. This effect leads to signal attenuation at higher frequencies, above 10 GHz, especially in tropical locations. The severity of this effect depends on factors like wave intensity, drop size, and temperature, making it a critical design consideration for high-frequency terrestrial and satellite communication links. The factors influencing rain attenuation between the heaven and the earth, according to Reddy 1981 and Adekunle 1997, are frequency, rain intensity, drop size distribution, and others. This subsection will be fully dealt with in the next inaugural lecture from our research group. My contribution to the body of knowledge in radio propagation studies. Number one, studies on radio refractivity. Our research group set up an experimental station for the continuous measurement of radio climatological variables at the Inaugural local government area of Ondo State in collaboration with the Meteorological Institute, Germany, University of Bonn, and the Center for Basic Space Studies, an activity center of the National Space Research and Development Agency, NASA. The fixed measuring method using a high power of 202-meter communication mass, as shown in figure 5A, was employed with integrated sensor suit weather stations, figure 5B, placed at 5 different various heights at intervals of 50 meters from ground surface to a height of 200 meters for continuous measurement of about 14 atmospheric parameters. The tower is owned by the Nigerian Television Authority, NTA, but not currently in use due to the relocation of the broadcast equipment to their present site along Ondo Road in Akure. So our research team, under the leadership of Professor M.O. Adekunle, approached the management of NTA for its use, and the management wholeheartedly released the facility with a room at the station, thereby making the tower available for experimental investigation of the vertical profile of radio refractivity studies over this region of Nigeria. Interestingly, only very few transmitting mass used for line of sight microwave communication in Nigeria are higher than 200 meters, thereby making the mass to be of huge interest for the study. The equivalent of the mass height can be found in Sokoto NTA station. However, FUTA is the only institution in Nigeria with these studies at the aforementioned heights at the moment. Figure 5D shows the block diagram of the equipment setup at the location. The calculation of atmospheric refractive index N is refractivity big N, and the modified refractivity F from measured meteorological parameters were done using equations 3 to 7. The vertical gradient of radio refractivity can be derived either in terms of the variation of refractivity with height or in terms of the modified refractivity gradient with height. Therefore, in terms of N and M, the propagation conditions are classified. Equations 8 to 11 as shown in Table 3. Adediji 2009, Adediji and Adekunle 2007, 2008, 2009, 2010, Adediji et al. 2010, 2011A, 2011B, Adediji 2011, Adediji et al. 2019. Using extensive data obtained from this setup, determine the statistical distribution of the diurnal and seasonal vertical refractivity gradient, its modulus, and the prevailing atmospheric condition at Akure. In this study, an example of the results obtained is shown in Figure 6A, which indicates that the propagation conditions have varying degree of occurrence in this region. The altitude of the studies deduce that subrefractive condition is prevalent from the ground surface to the altitude of 100 meters between January to May and at all levels from October to December, Figure 60. Subrefractive condition, on the other hand, is prevalent at altitudes above 100 meters from January to September, and from the ground to altitude of 50 meters from June to September. Therefore, for radio communication antennas in the height range between 100 meter high, subrefractive condition will cause reduction in the radio horizon. Adediji and Adekunle 2010 also investigated the seasonal variation of the vertical profile of the monthly mean modified refractivity in Akure. They similarly observed high values of mean modified refractivity in the rainy months, that is March to October. The monthly mean vertical profile of modified refractivity from the ground to the altitude of 200 meters is shown in Figure 7A. The seasonal variation of the modified refractivity, Figure 7B, also shows two minimal points in day and August. Other words include Dada et al. And Adediji 2020, Adekunle et al. And Adediji 2024. Adediji and Adekunle 2011, Adediji et al. 2013, Adediji et al. 2014A, and Adediji 2025. Using 3 years of measurement, Figure 8, obtain the average value of A factor for year 2007, 2008, and 2009, respectively as 1.69, 1.49, and 1.31, with an average value of 1.5 for the 3 years of the report. This is a useful tool for the various service providers and radio engineers in the country to adopt during link budgeting in order to mitigate against microwave signal degradation and enhance proper choice of antenna height, its geographic location, and the transmitter power. Adediji 2017A compared the surface radio refractivity and is reduced to sea level value over 3 different meteorological stations in Nigeria, Akure, Mina, and Nsukka. The result shows that surface refractivity has seasonal tendency and is highest in the wet season and low in the dry season months. Figure 9. Adediji et al. 2014B, 2014C, and Adediji 2017B. Compare radio free strength and horizon distance over 7 locations in Nigeria, and deduce that surface radio refractivity values are low during the dry season months, while fish strength variability FSB values were high, and as NS values were high during the wet seasons, FSB values were generally low. Typical results of the average FSB is given in 4. When atmospheric temperature and humidity distribution deviate from the normal or standard radio atmospheric conditions, the vertical gradient of refractive index will also deviate from the standard conditions. Adediji 2011, Adediji et al. 2013, Ojo et al. And Adediji 2013, 2014, 2015A, 2015B reported that propagation conditions have very degree of occurrence with super refractive conditions being mostly prevalent in Nigeria. Other words include Emmanuel et al. And Adediji 2017, Ashidi et al. And Adediji 2015. Adediji et al. 2012A, 2015, Adewale et al. 2020 investigated the influence of some methodological factors on the vertical distribution of tropospheric radioactivity over Akure. It was deduced that at all the levels considered, that is from 0 to 200 meters, water vapor pressure has the most significant influence on radioactivity. Also, Adediji and Ibadan 2024-2025 investigated the effect of temperature on radio dot propagation in coastal areas of Nigeria and deduced that radio dots which can trap radio signals in the coastal areas of Nigeria are formed at temperature of more than 26 degrees centigrade. Other ones include that Gada et al. And Adediji 2018, 2021, Eji et al. And Adediji 2015, Adediji et al. 2025. Ogunjo et al. 2014 investigated the forecasting of radio refractivity values over a tropical location. Preliminary results of the study indicated that reliable forecast can be made for 11 days ahead, which is in good agreement with the predicted and computed values, as shown in figure 11. Adediji and Ogunjo 2014, Ogunjo et al. 2012, Ogunjo, Adediji and Ada 2017 investigated chaos in the vertical distribution of radio refractivity over Akure. Results obtained showed chaotic quantifiers as ground level and height of 100 meters are more chaotic than at the two other levels, that is 50 meters and 150 meters. Ogunshua and Adediji 2018 computed radio refractivity at the surface level at 100 meter height, and the differential radio refractivity, the NDA for the years 2011 and 2012. It was observed that the Akinov exponent is generally positive, indicating the presence of chaos for all radio refractivity data sets, figure 12. This indicates the dynamical response of radio refractivity to varying weather conditions. Adediji et al. 2021 assessed the dynamics of microwave radio field strength over some selected stations in Nigeria by computing radio refractivity and the field strength on the basis of sets of measured atmospheric parameters. It was observed that the Akinov exponent over the study station were low with little variations from one another. It can be deduced that the source of the toxicity and dynamical complexity show degree of correlation between the two major parameters computed from the radio free strength. Computation of simple particle scattering parameters and rain attenuation prediction. My research work has touched on the very important problem of scattering of electromagnetic waves by hydrometeors, especially rain, by extensive computation of the scattering parameters associated with raindrops. Hence, Adediji 2003, Adewale and Adediji 2004, and Adediji et al. 2006 calculated the focus scattering amplitude and the propagation constant in the rainfield medium over two satellite angles of 23 degrees and 58 degrees, while using satellite communication in Nigeria. It was deduced that the specific attenuation generally increases with increasing frequency and rain rates, while for the phase shift, it was observed that the particle polarization was higher than the horizontal polarization at frequencies of 34.8 to 40 gigahertz. Adediji et al. 2006 calculated the focus scattering amplitude function from which the cross polarization discrimination XPG was obtained. The results show that SPG becomes poorer with increasing frequency and decreasing receiver elevation angle, while low polar attenuation simply increases frequency and wave rate. This implies that there will be significant channel interference between the wanted and unwanted channels. Ojo Adekunle and Adediji 2011 also investigated the cumulative distribution of cross polarization due to rain using 30 years of higher rainfall data obtained at 5 locations in Nigeria based on the ITUR model, and for 3 satellite loop angles of 23 degrees, 42.5 degrees, and 55 degrees respectively. The results, figure 13, obtained show that for 0.01% exceedance probability, XPD fell below the threshold of 30 dB on all the satellite currently used for communication system operating in Nigeria. Furthermore, Ojo et al. And Adediji 2010 presented results for the rainfall pattern, rain rate, distribution, and rain attenuation characteristics for application on terrestrial lakes over Nigeria. Figure 14a shows the average monthly rainfall accumulation for 30 years rainfall data at substations in Nigeria, while figure 14b shows the comparison between the rainfall in the arid and coastal regions of Nigeria. Ojo et al. 2016, Ojo, Adediji and Rabi 2016 presented rain characteristics and slant pattern attenuation at 30 and 40 gigahertz using synthetic storm techniques over 7 tropical locations in Nigeria. The predicted statistics are in good agreement with those obtained from the propagation beginning measurement. Other works include David et al. And Adediji 2020, Kolade et al. And Adediji 2022, Ojo and Adediji 2008, Rotimi et al. And Adediji 2010, 2011. Contribution to radio propagation at medium to very high frequency bands. Our group carried out measurement of electricity strength of the few remaining AM radios, FM radio and VHF to UHF television transmitters across Nigeria. Adekunle et al. And Adediji 2007 carried out a study of audio satellite communication system analysis in Africa. It was deduced that in clear weather conditions, the path loss capability exceeds the actual path loss of each channel, as shown in figure 18. Also, Adekunle et al. And Adediji 2013-2015 carried out measurement of the coverage areas of some AM medium wave transmitters over the landmass of Una State, as well as investigating the usability of the medium wave frequency band in deploying the advanced traveler information system (ATIS) of the Intelligent Transport System in Nigeria. The study figure 19 revealed that signals from digital transmitter provide wider coverage areas than signals from analog transmitter of the same transmitter path. Also, Adekunle et al. 2013 deduced a suitable calculation technique by which the service areas, that is primary, secondary, and fringe of AM and MF transmitters can be graphically represented. It was deduced that ranging method was the best suitable calculation technique for plotting coverage areas of broadcasting stations. Furthermore, 2 FM radio stations in Niger State have been studied. For the television station also in Niger State, 3 television stations were studied. The results obtained by Adekunle et al. 2013 revealed that for optimal coverage in the study areas, there is need for relay stations for the 2 FM radio stations to fully cover the state. Adekunle et al. And Adediji 2014, Adekunle et al. And Adediji 2015 measured the signal strength of the transmitter of Ondo State Radio-Vision Corporation at Akure, Oka, Akoko, and Okitipa. The overall result is that the significant effect of precipitation on the coverage areas of UHF television signal over Ondo State landmass. Other works include Adekunle et al. And Adediji 2017, 2018, 2019, 2020, Ojo et al. And Adediji 2021A, 2021B, Ayedra, Ojo and Adediji 2022. Rain rate conversion. Rain rate measurement and conversion to equivalent 1 minute integration time. In radio propagation studies, it is the rate at which rain falls that is important and not the amount of rain that falls along a radio link. The available 1 minute rain rate data measured by our research group through the use of the first micro rain radar (MRR) in the African continent, located in the Department of Physics here in Futa, is not enough for rain attenuation prediction across Nigeria. Hence, we need to convert the available rain rate data from other sources to the 1 minute integration time for radio propagation studies. Ojo and Adediji 2016 presented an empirical and dynamical model for converting rain rate of long integration time to 1 minute for a tropical location accurate. Several conversion methods figure 21 were also tested as suitable model was proposed for this region. Nurodola, Adewale and Adediji 2014 presented the statistical analysis of rainfall rates measured with high temporal resolution of 1 minute integration time during the occurrence of some rain events in Akure. It was deduced that rainfall pattern in Akure was mainly stratiform with less than 10% convective rains. Due to the inadequacy of the MRR equipment in many locations for in situ measurement of rainfall parameters, Kolade et al. And Adediji 2021 developed a rain radar simulator to facilitate ubiquitous use and application in weather and radio wave propagation and augmented available MRR measured data. The simulation validates that raindrop is sublate spheroidal in shape, figure 22. Rain rate measurement and conversion to equivalent 1 minute integration time continued. Also, Ojo et al. Reported the study of the joint statistics of rain rate and rain event duration for optimum design of microwave link in Akure. From the work, the average numbers of places with rain event duration exhibited an exponential dependence on rainfall rate with correlation coefficient of 0.94, while the average duration for different rain rates follow a parallel with a correlation coefficient of 0.96. Radio wave scintillation studies. Ashidi et al. And Adediji 2017-2021 utilized 3 years of major satellite radio beacons to examine the statistical and temporal characteristics of tropospheric scintillation intensity and amplitude on the earth-to-space link within Akure, Nigeria. The results indicated that there were very few occurrences of scintillation intensities above 1 degree in all the sampling intervals throughout the experiment. Other words, other scintillation studies include Ashidi et al. And Adediji 2021-2022, Mohammed et al. And Adediji 2013. Studies on antenna design. Due to the various drawbacks on some types of antennas in communication systems with regards to weight, reliable signal transmission and receiving, there is need to develop a lightweight, inexpensive and reliable antenna system that will be very useful for nano satellites, military operations, cell phones, and so on, and handles the signal frequency range effectively. Hence, Adediji and Bonchard 2019 presented an optimized inset-fed rectangular microstream patch antenna for wide max applications. When the antenna was optimized, it operates at an ultra-wideband antenna, resonating at 2.91 GHz, 3.1 GHz, 3.5 GHz, and 4.08 GHz. Table 8 the results are shown in Table 8. Also, Alawe et al. And Adediji 2024B simulated on the filler helix antenna using a computer simulated microwave studio at a target frequency of 1.5 GHz. It was observed in the simulation that the QAJ provided the acceptable gain of 2.8 dBi with an impedance bandwidth of 12% at the central frequency. Afolabi Ewetuman and Adediji 2024B designed and developed a novel CubeSat platform monitor for vertical measurement of weather parameters in order to evaluate the dynamic state of the atmosphere. The results of the measurement compare favorably well with those obtained with standard instruments. The result of the measurement is as shown in Figure 24. Atmospheric to space physics studies. Our research group, in conjunction with Atmospheric Physics Research Group of Adekunle University and University of Ibadan, conducted experiments on the measurement of some atmospheric parameters under the Nigerian micrometeorological experiment, NIMEX 1 and 2. During the measurement, Adediji and Adediji 2005 determined the variation of soil thermal properties with the amount of soil water content at the Agricultural Teaching and Research Farm at Adediji University. The results showed that the thermal properties vary with the amount of water content in the soil, and the estimated damping depth vary between 0.1 meter and 0.17 meter. Other works include Adediji et al. And Adediji 2006, Adediji et al. And Adediji 2007, Adediji et al. 2012, Kazim, Adediji and Adediji 2014, Adebayo et al. And Adediji 2017. What future has for radio propagation studies in Nigeria? Radio propagation studies in Nigeria are crucial for improving wireless communication systems, and the future holds promising. However, there are several drawbacks to its development, some of which are limited infrastructure, environmental factors, limited funding, data scarcity, interference, talent retention, regulatory framework. These challenges highlight the need for collaborative efforts to address these limitations and advance radio propagation research in Nigeria. Hence, key areas of focus are 5G and millimeter wave technology, ionospheric research, climate change and radio, space science and artificial intelligence, AI, Nigeria Space Symposium. Conclusion. The Vice Chancellor, distinguished ladies and gentlemen, in this lecture I have tried to cover the breadth rather than the depth of my research focus. It is no way saying that without radio communication, business will grind to a halt. Banking operations will be hampered. It will be difficult to place orders, and air traffic control system will fail. Insecurity will be on the increase. Telecommunication is also a very crucial tool in education, emergency communications and disaster relief services, international diplomacy, and so on. Simply put, life without radio communication and telecommunication in particular will be almost unimaginable. No doubt, there has been remarkable improvement in the provision of telecommunication infrastructure in Nigeria through the advent of the Global System for Mobile Communications, GSM. The Vice Chancellor, distinguished ladies and gentlemen, as I conclude this lecture, I hope to have illuminated the profound symbiosis between radio and the firmament. This marriage of heaven and earth is a testament to human innovation's boundless potential, a shining example of what can be achieved when science and imagination converge. The firmament, that vast uncharted expanse, has captivated humanity's imagination since dawn, and yet it is through radio technology that we've been able to unravel some of its secrets, to peer into the very fabric of space and time. We've discovered new worlds, new stars, and new galaxies, expanding our understanding of the cosmos and our place within it. This journey, however, is far from over. Let us therefore continue to innovate, explore, and push the frontier of what is possible. In the words of the great astronomer Carl Sagan, somewhere something incredible is waiting to be known. Let us go forth and uncover those secrets, armed with the power of radio and our insatiable curiosity. Recommendation: explore interdisciplinary approaches. Invest in radio methodology through astronomy infrastructure. Foster STEM education and outreach. Promote international cooperation. Push the boundaries of radio technology. Funding of existing pseudo radio science research centers. Teaching science in indigenous languages. Introduction of radio science as a course, at least at the undergraduate level. Research support by industries. Acknowledgement. Moreover, whom he did predestine, them he also called. And whom he called, them he also justified. And whom he justified, them he also glorified. Romans 18:30. Thus with deep gratitude and mouthful of praises I wish to first express my heartfelt gratitude to the Almighty and omnipotent God, the Alpha and Omega, the one who knows the end before the beginning, the giver of life, knowledge, and wisdom, for making me acquire knowledge and see me through this journey. He also made it possible for me to stand edge before this assembly and deliver this 192nd Inaugural lecture today. May his name be glorified. I am grateful to my late father, Prince James Adediji, aka, and my late mother, Mrs. Janet Ayola Adediji. My mother was a mother by excellence. She was a woman with unparalleled passion for education. She insisted that I must learn and labored tirelessly to achieve her aspiration on me, but death took her away prematurely. May the good Lord keep resting her soul in eternal peace. If there is going to be another life after this, she will still be my mother. I also extend my gratitude to my maternal grandfather, late Honorable Michael Fadon, who took up the responsibility of my secondary school education when my mother was hospitalized, and vowed that if the Lord granted him long life, he would sponsor my education to any length I wish to go in life, but also left before I completed my secondary education. Again, by his so impressive bosom of God, I would have been more fulfilled if the two were to be alive and be here seated today. I register my profound gratitude to my sister, Princess Eunice Omolade Adediji, whose rating of motherhood fell into her hand after the demise of her mother. She has not failed in the responsibility. May the good Lord grant you good health to live a very good life. I'm equally grateful to my other siblings for their role in one way or the other in my academic and career pursuits. Prince Abimbola Joseph Adediji, aka Abudeshowo, Prince Adekunle Emmanuel Adediji, and Mrs. Adekunle Christiana Ibiaras, and others. My sincere gratitude goes to my paternal brothers and sisters, Pastor Oluwatoyi Adediji, Mrs. Adeola Adediji, Mrs. Iyabode Adediji, Prince Olusegun Adediji, Prince Adewale Adediji, my financial dependent during my university education, and others. I express my profound gratitude to my maternal uncles and aunties, cousins and nieces for their kindness and efforts all of the time. Late Dr. Omotayo Adediji Falayayo, who partly sponsored my university education and from whom I became computer literate when computer was a myth. Mr. Samuel Oladinofado, the nature's gift to the family, who is my mentor in the family, and insisted that I must read physics. When he sent my young friend through postal order from Bauchi, he wrote family. I opted for physics and not mathematics for several subjects. Thank God I obey your command. Thanks very much and congratulations, sir. Mr. Oluwatoyi Fadon, Mrs. Felicia Iyabode, and others I also thank for their contribution towards my success. Special gratitude also goes to my in-laws for their fervent prayers and support at all times. Mr. Rasak Badmus, late and Mrs. Babalola Olomini, Chief Adeyemi Afolabi Fagilade, my advisor and marital consultant, and others. I remain grateful to all my teachers at all levels of my educational training. Mr. Adekunle Osuntuki, who endeared me to physics in Form 3. Professor Alex Adesina, my mentor from St. Andrew's College of Education to the University of Ilorin, he forced me into going to the Better by Far University instead of my dream of Afemi Awolowo University in Ife. Professor Mudati Oladele, my brother and graduates in Ilorin, and others. Professor Moses Solidari Adewale, my indefatigable MLA and PhD supervisor, who brought me to academics and has never become tired of mentoring in all areas of my life. He knows me and I know him. I deeply appreciate the contributions of some former Vice Chancellor of this great university for my career development, such as Emeritus Professor Adekunle, who is my academic grandfather and the pioneer head of our research group. He never ceased monitoring till date. Professor Adediji employed me as assistant lecturer. Professor Adediji appointed me as associate director, Center for Space Research and Application, CESA. Late Professor A.D. Daramola renewed my appointment in CESA. Professor J.A. Fuape announced my elevation to associate professor and full professor. The incumbent tireless vice chancellor, Professor Adediji Adediji, who usually called me as namesake, appointed me to pioneer the administration of our new Department of Education and Technology, the newly approved program of the university. I wish to express my gratitude to all former deans of the defunct School of Sciences since I started work in FUTA. Late Professor P.O. Ikrimorotu, my wedding reception chairman, and who always disturbed me during my PhD program with his usual question, Aburo, báwo ni iṣẹ́? And others. I equally appreciate the current dean of the School of Physical Sciences, Professor L.B. Adebola, and all the professors and other members of academic, technical, and administrative staff. My special thanks also go to Professor retired Professor Ajay of Chemistry Department, who also kept disturbing me during my PhD program with Adediji Professor M.O. Ajay, who has taken me as her younger brother since she knew me with her friend Professor M.O. Adewale. Professor Oke, my special mentor, retired Professor J.O. Adeyemi, Professor Kola Adeyemi, University of Benin, Edo State. I register my profound gratitude to the physics family of FUTA and all the staff members of the Educational Technology Department for the love and cooperation all of the time. Also appreciate all my former and present graduate students, some of whom are now colleagues for their love all of the time. I'm also grateful to Alexander Humboldt Foundation, Germany, Meteorological Institute, University of Bonn, Germany, the Center for Research in Instrumentation and Management, of the University of Assam, Malaysia, UPM, Center for Basic Space Studies of the National Space Research and Development Agency, NASA, Center for Atmospheric Research of NASA, located at Ayiba, the management of the Nigerian Television Authority, Akure, the Institute of Electrical Electronics Engineering, Malaysia. I so wish to place a record the invaluable support I received from my postdoctoral research supervisor to Professor Mahmoud Ismail. I thank my dear friend, Professor Jising Mani, for his hospitality and assistance throughout my stay in UK. Also, I recognize the invaluable support of Professor Mrs. Madina Abdullahi and all members of the staff of Space Science Center, ANCAS and UPM, and the Wireless Communication Network Research Group of the Department of Electrical Electronics Engineering of UPM, with all friends in the group's research laboratory. I also wish to express my gratitude to all friends at University Saints Malaysia, USF, University Putra Malaysia, UPM, and all friends at the African Secretariat, the Tenaga Estate, Kaga, Malaysia. It is with much pleasure that I appreciate the Lord Bishop of Kisha Northeast Anglican Diocese, Ipetu Kisha, Right Reverend Dr. Joseph Alaba Oloshola, and the Dean of the Cathedral, Venerable Michael Adekunle. I equally appreciate all members of the Cathedral Grace Group of St. Paul's Anglican Cathedral, Ipetu Kisha, under the leadership of my mentor, Church and Ontari Father, Chief Tunji Oluwatoyo. I also appreciate the prayers and support of all my spiritual fathers in the Mountain of Fire and Miracles Ministry, MFM, notably among whom are Dr. Dikwe Olukoya, Pastor Ayu Yamo, Pastor Ademola Adediji, Pastor Dr. Adeshina Akadiri, Pastor Sheikh Titus. I appreciate my brother, Pastor Dr. Olumide Odeyemi, former Pastor F.M. Geras, Malaysia, for deepening my spiritual life and assistance throughout my stay in Malaysia. I deeply appreciate all members of the welfare group of MFM Southwest Mega Region, members of the congregation of MFM Geras, Malaysia, Southwest Mega Region, and Southwest 132 for their love, prayer, and support. From the bottom of my heart, I wish to highly appreciate the entire members of the Immaculate Adediji, Oristo family Adediji, Equals Country Club Akure, the League of Friends Akure, Ogoluwa Landlords and Landladies Association Akure, Ipetu Arodo Citizens Akure, Ikejile High School Students Association, the International Union of Radio Science Nigeria, my former colleagues in Akure Secondary Commercial Akure, and all my former students at the secondary school level. Moreover, man is a function of the society. Hence, I appreciate the encouragement received from the following: Pastor Oluwatosin Owosheni, Pastor Mrs. Caroline Folashade, Mrs. Oluwayemisi Olowojesi, and others. I'm also very grateful to all my generation in Adediji who have been celebrating me since my appointment as professor, and thus nomenclate me Professor Otia, Professor Produced, and all our younger generation in the Adediji. Distinguished ladies and gentlemen, I wish to express my profound love and appreciation to my God-given son, Adekunle Adediji, the joy of my life. This achievement is as much yours as it is mine. Your patience and unwavering belief in me have been my driving force. I'm deeply proud of the young man you are becoming, curious, compassionate, and driven. These days, a testament to our shared journey. Keep reaching for the stars. I equally appreciate the support of my foster daughter, Esther Oluwatomisin Akiyemi, and my baby, Happiness Omalade Fakwade, who have been so wonderful to me. The Vice President, distinguished ladies and gentlemen, whosoever findeth a wife findeth a good thing, and obtaineth favor of the Lord. Proverbs 18:22. And behind every successful man is a very virtuous woman. It is possible for me to deliver this lecture today because of the support of my beloved, wonderful wife and partner, Mrs. Mercy Apostle Adekunle Adediji, who is the anchor of my life and the catalyst of my dream. Our unwavering support, boundless support, and boundless love, unrelenting encouragement, and resilient prayers have prepared me to this pinnacle of academic achievement. This professorship is a testament to your strength, wisdom, and unwavering faith in me. You are my partner, confident, and will forever be grateful for your love and education. Thank you for your support through the years. Distinguished ladies and gentlemen, it is God that guided me with strength and made my way perfect. He made my feet like hands' feet and settled me upon my high places. He teaches my hands to walk so that a bow of steel is broken by mine hands. Psalm 18:32-34. Therefore will I give thanks unto thee, O Lord, among the heathen, and sing praises unto thy holy name. Psalm 18:49. In essence, this is the Lord's doing, and it is marvelous in my sight. Thank you all immensely for listening to my story.
Can we have another round of applause for our inaugural lecture? Please be seated. We thank you, Professor Adekunle Titus Adediji, for this well-delivered inaugural lecture. I don't expect anything less from my half-namesake. Ladies and gentlemen, it is customary for us to acknowledge the presence of some special persons amongst us. We start from within, and therefore I'd like to recognize a former registrar of our university who is also now a professor, Professor Odupe Ajayi, Assistant and thank you, ma'am, for coming. We also have with us today former librarian, Prince Adekunle Adediji. Thank you, sir, for honoring us with your presence. We have with us also a former acting university librarian, Mrs. Zainab Falayi. Thank you, ma'am, for always coming. As we marched in this afternoon and I saw one of us, a former member of Governing Council, I said truly today is his academic birthday. I'm talking about no other person, the mentor of our inaugural lecturer, Professor Moses Ajewole. Thank you, sir, for coming. Thank you for mentoring Professor Adediji. We appreciate you and we respect your wealth of knowledge. Thank you, sir. We have also with us a former member of our Governing Council, the professor that is okay. I mean, very okay. Professor Okay. Thank you, sir, for always coming. He's the only professor that is okay amongst us. We have with us this afternoon a professor and from the is the research director, National Space Research and Development Agency, Abuja, Professor Adekunle, who is ably represented by Pastor Shola Akin. Thank you, sir, for coming. Distinguished ladies and gentlemen, when you have professors here, you must definitely have the Royal Majesties and the Royal Highnesses that made him. He has thanked them, but customarily we have to recognize our KBCs. We have with us this afternoon His Royal Majesty Oba Adeleke Agunbiade the Ajanaye of Ikwetu Kingdom. Thank you for coming, sir. Adekunle, that I'm we also have with us His Royal Majesty Oba Engineer Moses Agusuri, the eminent God of the nation. His Royal Majesty Oba Adediji, the honor of Omo Ijesha. Please, I think somebody should be putting a mark on top of this thing. We put Doremi, we know how to, but please pardon my pronunciations. His Royal Majesty Oba Roga Akibayode, the Alapeju of Inupeju, Ikwetu Ijesha. We also have with us His Royal Majesty Oba Oladele the Olu of Afibio Ikwetu Ijesha. Thank you for coming. And His Royal Majesty Oba Mutajeru Akoti, the Ayanuga of Akoti, Ikwetu Ijesha. Thank you, Majesty, for coming. And to all our KBCs who say, Adekunle, but Adekunle, Ebugere Afelowo, Ashekunle. We thank you so much, sir, for honoring us with your presence and for making this our professor. We also have with us Chief Adeyemi Afolayan, excellent of Ikere Ekiti. Thank you for coming, sir. Today we also have with us Right Reverend Dr. Joseph Alaba Olushola, the Lord Bishop of Ijesha North East. Our Lord Bishop, thank you, sir, for coming. Venerable Michael Adiri, Dean, St. Paul's Cathedral, Ikwetu Ijesha. Thank you, Dean, for coming. Chief Tunji Oluwatayo, retired President of Lagos State. Thank you, all the way from Lagos State. We have with us Honorable Adediji Badere, the former Commissioner for Water Resources in Osun State. That is our state. Thank you very much, sir, for coming. We have also with us Chief Firmament, President, Adediji High School Old Students Association. Thank you, Excellency, for coming. We have with us Honorable Pastor Ayo Mishade, Superb Secretary. Thank you, Honorable, for joining us today. We recognize all the members of Adediji High School Old Students Association. Please, if you belong to the association, kindly rise for recognition. Adediji High School Old Students Association. Thank you very much for joining us. We have some other members of the family of the inaugural lecturer. We have Mrs. Adediji Blessing, family members. Thank you for that's not the wife. We have Mr. Adediji Oluwatuyi. Thank you, sir, for coming. Mrs. Olushola Adediji, thank you for coming. We have Ms. Tominsin Akiyemi, foster daughter of our inaugural lecturer. Thank you for coming. We have Badamosi Eunice. Thank you, Mommy, for coming. And our mother in Israel, C.T. Fagbo. Thank you, Ma, for coming. We also have Mrs. Fagbo Shew. Thank you, Ma, for coming. We recognize the son of our inaugural lecturer, Adediji Ifeoluwa. Thank you for being the God-given son of our inaugural lecturer. Distinguished ladies and gentlemen, we also have with us a woman that is of double honors. The inaugural lecturer has described her as a wife and a partner. In his words, he described her as the anchor of his life and the catalyst of his dream. He described and recognized our unwavering support, our boundless love, unrelenting encouragement, and resilient prayers. Distinguished ladies and gentlemen, we have Mrs. Adediji Mercy, the wife of the inaugural lecturer. Thank you, ma'am, for your boundless love, for your support, for your prayers, and the encouragement that have strengthened and embodied our inaugural lecturer. Thank you, ma'am. We have here in our midst the most important group of persons in this assembly today. Great Rotarians, you are the most important and you are the best. Thank you for coming.
A couple of announcements before we take the answers. MFM pastors and members receive seats accommodated at the 25 Papa just outside there. Okolua community, please, you are also enjoined to move to the Papa. Professors here present, please, yours will be just at the entrance of 25. Ikwetu citizens from Ikwetu and people from Ikwetu community, please, your package 2 is to be taken at 2-5. University staff, please kindly move to the front of the 2,500 auditorium for your packages. Students are lent to be given tickets, so please, that will be after the procession of the Vice Chancellor. Distinguished ladies and gentlemen, having come to the end of today's inaugural lecture, shall we all rise for the future and the national anthem? auditorium in a reverse order. We shall remain standing.